All right, boys and girls, welcome back to the drive-thru as I make my way through my fears and I continue on to the second video of this analytic trig chapter. Okay, so here are the things that you're going to be able to do. These are your I can statements. Okay, and you're going to be tested on those things in your Math Excel. Not tested on them, but you're going to figure out whether or not you're doing them right by practicing in Math Excel. My first thing I need to do in order to get you to understand how to do these things is explain. Hopefully you can reference the equation sheet. Remember, you can have that sheet out for all of this. I'm not expecting you to memorize any of this. I hope you memorize that sine squared plus cosine squared equals 1. Here's what this means. Sine of, I'm not going to use u and v because they look the same. I'm just going to use x and y. So the sine of x plus y is equal to, notice, this has the plus on top and the plus on top. So it's the sine of x, cosine of y, plus cosine of x, sine of y. Okay, that's how you interpret that. But here's what gets weird. If you look at the cosine of x plus y, notice this one is a plus and this one is a minus. So it's telling you have to switch the sign. So the cosine of x plus y is cosine x cosine y minus sine x sine y. So you'll also notice that on the tangent one, the positive stays positive on top, but is a negative on the bottom. And I just kind of wrote over it. The negative, the subtraction, is a negative on top and a positive on the bottom. So that's how you use that formula. That's how you read those formulas. And from here, we're just going to go into two examples. These are actually right off of your homework. So, use the formula for the cosine of the difference. So what is this doing? It's actually saying, well, like if we wanted to find the cosine of negative 15 degrees, oh, well, we don't know how to find that as an exact value. We could put that in our calculator. So we're going to call that the cosine of 30 minus 45 because those are special right triangles. So the cosine of 30 minus 45, notice the minus turns into a, sorry, it stays a minus. Is that what it says? No. The minus, sorry, turns into a plus. So we have to do cosine 30, cosine 45, plus sine 30, sine 45. Okay? So let's draw a 30, 60, 90 triangle out real quick. This is 1, 2, radical 3. Let's draw a 45, 45, 90 triangle out real quick. That's 1, 1, and radical 2. You need to bring that knowledge with you from geometry in order to be able to do this problem. That's why I love this setup we have in here where you're constantly building on the things that we learned in prior courses. That way we're not wasting our time. So, what is the cosine of 30? Adjacent over hypotenuse, so this is radical 3 over 2. What is the cosine of 45? It's 1 over radical 2. Plus, what is the sine of 30? That's 1/2 times, what is the sine of 45? That is also 1 over radical 2. Okay? So, you get radical 3 over 2 radical 2 plus 1 over 2 radical 2 The denominators are common, so we can just write that as radical 3 plus 1 over 2 radical 2. Now, your Math Excel is not going to let you write a radical 2 on the bottom, so I have to rationalize this thing. On the top, radical 2 times radical 3 is radical 6. Radical 2 times 1 is radical 2. That is not radical 8. On the bottom, you get 2 times radical 2 times radical 2, which is 2 times 2, and you just get 4. That is your exact answer, okay? Okay, so let me show you how to check your answers on this. If I do parentheses, radical 6 over plus radical 2 over, close your parentheses, divided by 4, I get that. Now, what is the cosine of negative 15? Let's see, am I in degrees? Let me see if I'm in degrees. I'm in radians, so let's switch it over to degrees. And then go back to my screen. Cosine, negative 15. I hope it gives me the exact same decimal. Yes. Okay, that's how I know I did it right. On to the next one. All right, so now we got a similar question, well, a similar concept, harder question. This is your trig proof. So we're trying to prove that the cosine of alpha minus beta over the cosine of alpha times the cosine of beta equals 1 plus the tangent of alpha times the tangent of beta. All right. So, since this is in this section, I got a feeling we're going to change the top. So let's rewrite the top. Cosine of alpha plus minus beta is cosine alpha, cosine beta, plus, we got to do the opposite of that sign, sine alpha, sine beta, all over cosine alpha, cosine beta. And we're trying to prove it that equals 1 plus tangent alpha, tangent beta. All right. Well, what can we do with fractions? We can separate them by their denominators. So, cosine alpha, cosine beta, divided by cosine alpha, cosine beta, plus sine alpha, sine beta, divided by cosine alpha, cosine beta. Ah, what is this? That's 1. What is this? What's sine divided by cosine? Tangent. Boom!